So now that we've read the biblical creation story from the book of Genesis, let's take a look at what science has to say about the creation of the universe. More importantly, we'll look at how the science developed down through the years. Now, if you go back to the time that the Bible was written, ancient astronomers used to look up at the sky, and they noticed that all the stars were moving, but they moved together in a group, almost like a flock of birds or a school of fish would do. The stars didn't seem to be moving relative to one another. Not only that, every night the stars would return to the same positions, although the stars that they saw in the summertime were somewhat different from the ones that they saw in the winter. Well, eventually, astronomers figured out that the stars actually weren't moving at all. What was going on was the Earth was rotating with us sitting on it, and that was causing the stars to appear to be moving. And so they concluded that the stars weren't actually moving at all. By the 16th century, science had come to the conclusion that the universe was static and unchanging. And this was the predominant school of thought right up until the 20th century. And so, since the stars didn't appear to be moving, scientists reasoned that the universe had been here forever. It had no beginning, it had not been created, nor would it ever end. This idea became the cornerstone of all astronomical science and remained that way right into the 20th century. In the year 1917, which is not even 100 years ago, Albert Einstein wrote a paper in support of this idea, saying that the universe was infinitely old and unchanging, that time had no beginning and would have no end. Therefore, most scientists agreed with him that the universe could not have been created, and therefore there were fundamental contradictions between science and religion. But then, in the year 1927, one scientist made an interesting discovery, one that would upset the theory of a static universe. That astronomer's name was Georges Lemaitre, and in 1927 he observed that all of the galaxies in the night sky actually were moving. The reason that ancient astronomers had not noticed this was because they were moving away from each other and from us. Lemaitre was the first scientist to realize that if all the galaxies are moving away from one another, well, that means that at one time, long ago, they must have all started from the same place. Scientists had long believed that the universe was static and unchanging, but Lemaitre proved that this was wrong, that in fact the universe was changing. It was expanding, and at some point in the past, it had all started from a single point. And that meant that the universe had had a beginning. Now, this idea that the universe had a beginning was a complete shock to scientists, virtually all of whom believed in the idea of a static universe that had no beginning. And so they attacked Lemaitre's idea, calling it religious pseudoscience. Now, take a look at Georges Lemaitre. How do you suppose they attacked his idea? Why did they think his idea was religious in nature? Well, you only have to look at the collar around his neck to answer that question. Georges Lemaitre was not only an astronomer, he was also a Belgian priest. Now, at the time, an astronomer named Fred Hoyle mocked the Lemaitre theory by giving it a funny name. He called it the Big Bang Theory. Not this Big Bang Theory, this one. Today, the Big Bang Theory has been accepted by the vast majority of physicists as the most accurate scientific explanation of how the universe was created. It says that the universe began in an event that Fred Hoyle called the Big Bang that happened some 13.7 billion years ago. This includes space, time, and all of the stars, planets, galaxies, and other objects in the universe. So let's take a look at this Big Bang theory to try to understand what it actually says. Remember that for a long time, scientists thought that time was infinite and had no beginning. The first thing to understand about the Big Bang is that it says that time, in fact, has a beginning. The beginning of time, and in fact the beginning of the entire universe, took place some 13.7 billion years ago. It was this event that marked the beginning of time, and although it also marked the beginning of our universe, it didn't look very much like the universe, at least not as we know it today. In fact, for a long time after the Big Bang, the entire universe was totally dark. There was no light. It would take some 300,000 years before parts of it began to glow. 9 billion years later, some of this glowing material had coalesced into the objects that we would call galaxies, stars, and planets. Our own planet, the Earth, was formed about 4.6 billion years ago, but once again, it would have been difficult to recognize, because at first it was little more than a ball of molten rock floating in space. It would take another billion years before the Earth cooled off enough to allow the first very simple forms of life to appear. And it would be another 3 billion years after that for these first primitive life forms to evolve into things that we might recognize as animals. For example, the first fish appeared just a bit more than 500 million years ago, and the first mammals showed up about 0.2 billion years ago. Now, there's one more thing about the Big Bang Theory that you should know for this class. The theory states that the universe began as a very hot, dense collection of particles. Lemaitre called it the primeval atom. Now, 13.7 billion years ago, this collection of particles began to expand very rapidly. And as it expanded, it formed all of the galaxies, stars, and planets that we see around us. That includes us. The rate at which it expanded turns out to be extremely important. Why is it important? Well, let's take a look at what would have happened if the rate of expansion had been just a little bit different, maybe just a little smaller. If the rate of expansion had been too small, then gravity would have quickly caused the new universe to simply collapse back into itself, and it would have wound up right back where it started, with a little ball of particles. What if the rate of expansion had been a little bit too large? Well, in that case, the universe would have simply flown apart before any stars or galaxies would have had a chance to have formed. What I'm trying to get at is that the rate of expansion had to be just right in order for the universe to form in the way that it did, a way that is hospitable for life forms, such as ourselves, to exist. If it had been off by just a tiny bit, by as little as 1 quintillionth, that's 1 followed by 18 zeros, we simply wouldn't be here, because the universe wouldn't have been a place where we could have lived. It's almost as if the Big Bang had been fine-tuned to result in a universe that was specifically suitable for the formation of life. How fine-tuned was it? Well, imagine for a moment a nice sandy beach. Now imagine all of the sandy beaches in the world. Scientists estimate that if you were to count up all the grains of sand on all of the beaches in the world, there would be just about a quintillion of them. So we'll let the number of grains of sand on all of the beaches in the world represent the rate of expansion of the universe. How many grains of sand could we remove before we caused the Big Bang to fail and generate a universe that simply made life impossible? Well, it turns out the answer is 1. Starting with all the beaches in the world, if you removed one single grain of sand, that would have been enough to spoil the universe. That's how finely tuned the universe is. So finely tuned, in fact, that most scientists agree that there's no way that it happened just by chance. In other words, science seems to be pointing to the possibility, at least, that somebody or something must have tuned the Big Bang to create a universe that would be hospitable for life as we know it, including ourselves.